Okay, in this podcast we're going to talk about displacement reactions, or sometimes they're called replacement reactions. We're going to skip those couple of slides on oxidation or redox, and we will do redox when we get to electrochem at the end of the year. So if we're looking at displacement reactions, we're looking at can a piece of metal replace a positive ion that's part of a solution. So, if we wanted to know whether or not this will produce a reaction, added copper metal to HCl, we need to think about the copper and whether or not it is more reactive or more active than the hydrogen, because it would replace the hydrogen, it wouldn't replace the chlorine, right? So what we could do is look at this, what we call activity series. And the way this works is the element at the top, the metal at the top, is the most reactive. Not surprising, we got the group 1 elements at the very top, and the group 1 metals are going to be the most reactive. And on this table, actually, everything is compared, the reactivity is all compared to hydrogen, which is why it's in blue. When we get to electrochem, we'll actually have values that we put on these voltage numbers. But what has to happen is, in order for that copper to replace the hydrogen, it has to be more reactive. And if we look, copper is in a lower position than the hydrogen, so it is not reactive. So we would have no reaction. Nothing would happen. However, if we were to take copper metal, here we have a piece of copper metal, atoms touching each other, and we put it in a solution of silver nitrate. And of course, if we have a solution of silver nitrate, because it's soluble, we're going to have silver ions and nitrate ions hydrated and floating around. So if I were to put copper into a solution with silver nitrate, now the silver is in a lower position, which means the copper is more reactive. So this reaction will occur. So what happens when it occurs is the copper replaces the silver, and I know it's copper 2. I wouldn't expect you to know it's copper 2 unless I told you. And so this is aqueous, so now I have copper and nitrate floating around, and I end up with silver metal. And you may have done this reaction in Chem 1. You end up with, you can see the silver looks almost like rust. A lot of students will say it's rust on top of the copper, and eventually it will fall down and it's real silver. And we will see copper nitrate solution, and what you see happening is this solution actually starts to turn blue, and that's because copper plus 2 ions, which is what we have here, are blue when they're in solution. So this would be the double replacement reaction. And what we know is the reverse reaction, if I were to add silver to copper nitrate solution, it would not occur. And that is because the silver is not as reactive as the copper. Alright, that's just my dog Bobo. Okay, so if we look at this reaction, copper metal displaces the silver ions, causing the silver metal to plate out. So let's write the full reaction, and then we'll write the net ionic. So the full reaction was copper solid plus silver nitrate becoming copper nitrate plus silver, right? And I'm going to need 2 nitrates, so I need 2 silvers. Okay. So the copper is not an ion here, right? Copper is a solid, but I have silver plus 1, 2 silver plus 1s because there's 2 of these, plus 2 nitrate minus 1s, becoming copper plus 2 nitrates, which is aqueous, and these are aqueous, and silver metal. So let's write the net ionic. The only thing that falls out, because it's on both sides, are the 2 nitrates. So I have copper solid plus 2 silver plus, becoming copper plus 2 silver solids. And the plus 2 copper and the plus 1 silver are both aqueous. So that would be the net ionic. All right, we're going to stop it right there.